Hi, everyone, and welcome to the USC Viterbi School of Engineering Faculty Roundtable for the Sunny Estani Department of Civil and Environmental Engineering. My name is Paul Ledesma. I'm the Executive Director of Undergraduate Admission here at the Viterbi School of Engineering, but I am the least important person here today. This is an opportunity to get to know some of the faculty from the Civil and Environmental Engineering Department, so you can learn a little bit more about everything that they do inside of that department as you might be considering that for your degree in college. First, what we're going to do is I'm going to have each of the faculty introduce themselves, tell you a little bit about their background, how they got here, what they do here, and then we will get into the rest of the session. Please do not raise your hand. I cannot call on you. We're going to go through this session, and we're going to make sure that we get into all of this information as we get into it. So, first off, I'm going to start with Amy. Amy, why don't you go ahead and introduce yourself?
Hi, everyone. Welcome. My name is Amy Rechenmacher. I'm a teaching professor in the Department of Civil and Environmental Engineering here at USC. I was formerly tenure track, and that just wasn't my path. I like teaching better. My expertise is in geotechnical engineering, so landslides, underground construction, anything having to do with the subsurface. I worked in practice for a few years before getting my PhD. And I've been at USC now for 20 years, and I manage the undergraduate American Society of Civil Engineers student chapter.
All right, thank you very much. Jiachen.
Hello, everyone. I'm Jiachen, Assistant Professor of Environmental Engineering. My expertise is in urban climate and air quality modeling. And when I give educational presentations at high schools, I give the question like, have you ever played Minecraft? So to me, it's like the models that we use are like, building a Minecraft, but instead of chasing zombies, we're chasing the flow of heat and air pollutants. So I just joined USC as assistant professor last January, but I actually graduated with my PhD in environmental engineering from USC in 2019. So I was really excited to go back to my home, and I can testify that USC is a great university to be in, especially this department. And just to talk a little bit about my gap between my graduation from my PhD program and last year, I worked at the California Air Resources Board. Policies related to zero emission vehicle adoption and their impacts on air pollutant emissions. So my point is that I feel like if you study this major, you're gonna play an important role in shaping the future of our policies and cities. So that's my advertisement for the department. I guess I can pass it to Thomas.
Great.
Yeah, so good afternoon, everyone. I'm Thomas Peterson. I'm also an assistant professor. I think I started maybe half a year before Jiachen did, so I've been at USC since 2022. I did my undergraduate degree at North Carolina State University and then got my PhD at MIT in mechanics of materials. I spent I spent 3 years at ExxonMobil as a research engineer in kind of well construction, how to build wells, drill wells. And then since that time, so basically after COVID, I came to USC, and I've been really enjoying it here, working primarily on electrochemistry and electrochemistry in porous materials. So I'm interested in all things kind of porous materials that can be cement, that can be kind of membranes, that can be flow through geologic media. And I teach at USC as well. So I teach 2 classes, fluid mechanics and solid mechanics. So I really am kind of focused on that area of mechanics.
All right. Great. Thank you so much. Thank you again to our faculty for being here today. For all of our audience, I'm going to tell you how today's going to go. I'm going to lead the discussion for the first half of the session, where we're going to talk all about the discipline, the curriculum, the research, kind of dive into everything that we want to know about the department and the majors. And then as we get towards the latter half of the session, don't worry, I'll cue you. I'm going to open up the Q&A. And so it's closed right now, but the Q&A is going to be an opportunity for you to pose your questions to the faculty, and then we're gonna answer those questions, whoever is the most popular, because as we also open up the Q&A, it's going to open up an opportunity for you to upvote the questions. And so as you see questions that go into the chat, you have the opportunity to thumbs up them and push them up to the top. We'll answer the questions in the order in which they're listed there. Now, it's important to note that these are questions about the discipline, about the curriculum, about the majors, about the research, but it's not about admission, okay? So today's event is not about admission. If you have any questions about admission, I'm putting a link into the chat right now that you can register for one of our admission events, either on campus or virtual, and that's where we'll be able to discuss everything else about the school and about the admission process. But today we're focused on civil and environmental engineering. So let's get started. First off, probably the easiest question for me to ask, but also probably one of the hardest questions to answer because of the complexity. What is civil engineering? What is environmental engineering? And maybe we'll start, Amy, I'll start with you. If we talk, maybe we can handle you, start with what is civil engineering, and then maybe we'll go to Jiachen for environmental engineering to explain that as a discipline, what we go over. And then Thomas, if you want to jump in, of course, wherever you want to go to. But Amy,
Sure.
why don't you kick us off with civil engineering? What the heck is it? Is it just making bridges?
Well, that's one part of it. Civil engineering is any engineering that relates to the creation, maintenance, and enhancing the effectivity of civilian infrastructure. So supplying, finding a source of clean water. And if you can't find a source of clean water, how do you clean it and make it clean? Providing any kind of facility for work or living. So the building that I'm in right now, you can't see the background, was designed and built by civil engineers. Creating a safe living environment in terms of working with Mother Nature. So here in Southern California, we have a lot of mountains and hillsides. Very often we encounter landslides. There can be floods, and even I grew up in Illinois, there were often floods when it rained really hard. So how do we manage that flood water? How do we manage the landscape so that we can function in it? Treatment of the waste that we produce. And that's a very important part. When you throw your trash away or when you flush your toilet, where does it go? It goes somewhere, and civil engineers work on the science and engineering managing that. And finally, to get to what Paul talked about, how do we get around? We use transportation. And that can involve bridges. And so on the structural side of getting around, building our buildings, we work a lot with architects. We need to have our space, and we have several faculty members who focus on this, thinking about space in terms of usability, lighting, fresh air, climate control in a way that is not so energy intensive. I just heard a statistic that buildings are one of the highest, I don't remember the exact statistic, one of the highest generators of users of energy in our society. A lot of people think automobiles use too much energy, buildings. So managing and making them more efficient. And also, as what Thomas does, all of these things that we build and implement are made of materials. And these materials need to be resilient. They need to be produced in a way that's not energy intensive. And we need to anticipate what's the worst wind force, what's the worst earthquake force, what's the worst snow load that we can think of, and how can we design these materials so that they're functional to meet our needs, but that they don't fail or deform or wear out too quickly. So I'm sure and then of course Jiachen can talk about air quality. This is something else that wasn't necessarily an issue 100 or 200 years ago, and then came the Industrial Revolution and auto use, and here we are. So I'll pass it to Jiachen.
Engineers with solutions that earlier solutions to earlier problems create new problems.
Well, that's absolutely right. So that's why we need environmental engineering to fix all the problems caused by civil engineering. But
And mechanical and all
well,
the
you
other
true. Yeah, very true. Yeah, yeah.
combustion.
So
Yeah,
we're the saver of all the different engineering
you are.
disciplines. No, we're just kidding. But we focus on applying engineering principles to evaluate and protect and improve environmental quality. And by that, we mean not only air pollution or air quality that I focus on, but also water quality and the impacts on human health. And also, I think we have many faculty members at our department who are specialized in the treatment of water and wastewater. And that's an important field as well. And in addition to that, we also had a new faculty member who brings expertise in like the soil contamination as well. So basically, environmental engineering cares about like all these different aspects of the environment. And we part of our job is to evaluate how serious the problem is. And by that, we could use computational tools like my Minecraft models,
Mhm.
or we could use experiments and field work. So if you like hands-on work, you have a place in the water lab, and but if you or in the air quality monitoring lab. But if you like to work with your computers, you also have a place like in my lab or other professors' lab. Oh yeah, so that's the first point. Like we want to know like how serious the problem is. And then after that, we want to know like how can we treat that? How could we improve, air quality or water quality? So in my lab, we look into, how different policies could improve air quality, like adopting more like lower emitting cars, for example, or like Amy mentioned, more efficient buildings. In other labs, they could look into the particular technologies like membrane technologies in treating drinking water or wastewater. So there are different methodologies that we apply to understand how serious the problem is and to treat the problem. So I think there's just a very interdisciplinary field, and we also work with colleagues in other fields as well, because a lot of these problems requires collaborative efforts to address.
Great, thank you,
Yeah,
Thomas.
I
Anything
agree
you want to add?
with everything that Josh and Amy said, and how they think they did a really good job of defining civil engineering, environmental engineering. I think our department, or this kind of discipline of civil and environmental engineering, is one of the coolest to study, because the problems are the problems we need to solve are of great consequence, right? And require quite a bit of interdisciplinarity. So, you know, we are right at the interface with society, right, with community. We're directly impacting the way people live their daily lives. And the way you can do this is, from the atomic scale, the material scale, all the way up to kind of the built environment of like structures, or even larger, the way Joshin is kind of studying maybe even climate patterns, and how climate patterns are changing, and how that affects pollution in a given city, right? So, how do you solve these problems? Well, it's definitely taking information from the kind of frontiers of science and engineering now, things like AI, things like new knowledge on climate science, things on like new technology with robotics and stuff like that, smart cities, and trying to use those forces to hopefully create better communities, more enjoyable communities to live in, right? That can sustain for future generations too.
That's great. Thank you. So, given that our audience is mostly high school students and their parents, and they're thinking they have some sort of interest in all the things that you've said, how can we best describe the types of classes that they will take? What's the curriculum like? And I guess I don't think we need to go through a lockstep version of exactly what classes they take in what order. I'm not going through that, and I can provide a link to our audience to make sure you can see the curriculum plans. But can we explain kind of the broad strokes of the progression of the degree program? What are the types of classes they will take? What will they do? And obviously, feel free to highlight courses that you all teach. I don't know whoever would like to start with this one.
Well, if so, civil and environmental engineering are linked because they both work together to solve the problems that Thomas was just talking about. So very traditionally, the city of Los Angeles or the city of Chicago or whatever engineering department has civil and environmental engineers on staff because they have to work together. All of these systems integrate together. But as you may imagine, environmental water quality and wastewater quality requires significantly more biology and chemistry. And on the solid side of things, buildings and bridges and slopes and retaining walls, those require a lot more physics. So usually, before you can actually start doing significant amounts of engineering, you need some of those sciences. So that's where you start out. In our department, we have an introductory environmental engineering class and an introductory civil engineering class. So the very first semester, you're getting to know your classmates in your major. You're working with them, you're solving problems, you're hearing about exciting new technologies. And then also in the freshman year, we have a graphics class that many of our students like. As you may imagine, there's a lot of computer-aided design that we use. And so those we do that very early on because it's used so often, and very exciting. Many of our students get summer jobs because they have these graphic skills that a lot of employers need. In addition, there is some. We firmly believe that computational modeling is going to be required of most engineering fields. So we also have a freshman level class. So you will be with other civil engineers right from freshman year. And then most of our curriculum proceeds, like many other universities, we are bound by the Accreditation Board for Engineering and Technology. This is, you may have heard this from other schools you visited, or you might have heard from it or seen it on websites. ABET accreditation certifies to practicing engineers that we have the schools, the skills, not just the math and science and the ability to do design, but we also have the teamwork skills. We have the communication skills that practicing engineers will need. So our curriculum starts from the basics, but we do have courses where we get our students together in the freshman year so that they start developing a community really early on. And then in the sophomore year, you start getting into more and more civil engineering specific classes. And I don't want to monopolize, but another unique thing about USC is we have a fairly robust general education program where students have to take categories of different courses outside the engineering discipline. And this helps to create a more rounded community of engineers, because engineers will be interfacing, as Thomas said, with the community. So having the skills and the ability to look at what's going on in the world outside of engineering is something that USC takes very seriously.
Thank you.
Yeah, so exactly. I think at the beginning you're building your foundations. You're probably seeing a lot of students across Viterbi, not just civil engineering, and then you start taking more foundational classes that are specific to civil and environmental engineering. So you'll probably be in this in the cohort with the department, and then as you move on, you'll even specialize more into kind of environmental or civil engineering kind of design courses that help you understand how to take what you've learned and put it to practice, right? These governing principles of engineering and physics. How do you actually translate that into designing engineering systems where you have to know things a little bit about like Amy was mentioning at the beginning, what types of wind loads do you expect? Well, there's probability distributions affected with that. How do you take those probability distributions into account when designing the column or the foundation of a building? We're also in California where there are earthquakes, right? So all those things kind of come into play. And I would say that our department in particular is very well linked to industry. So some of the design classes also you get to interface a little bit with practicing engineers, right? As well as potentially have the opportunity to go out and do externships or internships in companies around Los Angeles or elsewhere, even in the US.
Wow. I think you guys just gave a wonderful overview that I don't have anything that I could add to. But
That's okay.
yeah, but the point is that, you will take both fundamental courses and then courses more specialized to civil and environmental engineering. I will make sure that you're well prepared for the job market. Yeah.
Absolutely. Absolutely. I think one of the things that I would always like to highlight is that different than other universities, you actually take civil and environmental engineering courses immediately when you get here. That intro course load is right when you get here. And so the opportunities to engage and to understand whether it's right for you happens right from the get-go. And I put a link in the chat for everyone to see the full degree plans. And one thing you might notice is that there are these numbers of disciplines that are, or sorry, emphases that are inside of the discipline of civil or environmental engineering. And I just want to note right now, you don't need to worry about it. You're not expected to understand whether you want to emphasize or have a specialty in construction management versus structural engineering versus water resources. A lot of these things end up happening as kind of an evolution. As you go through the experiential process of taking courses, you will naturally gravitate to certain things. And whether you like water, whether you like the structural elements, whether you like to go into the construction side of things, these are things that happen over time. They all start the same way. The one thing to keep in mind that is different is building science. If you are interested in building science, which is the combination between civil engineering and architecture, it is a good idea to know that coming in. So if you're all thinking about that, that is where you would want to start. But recognize on our application, we don't even allow you to choose those things because it's a little confusing. You're just choosing whether you want to study civil or environmental, and that flexibility exists throughout the program. Students are often kind of evolving and changing as we go. So don't put too much pressure on you to have this all figured out before you get here. That's part of the process of being engaged in the curriculum and working with faculty such as these. So keep that in mind. Let's switch gears a little bit and talk about research. Students often hear about this Disneyland of research that goes on at universities and how they all want to do research, and it's a glorious and wonderful thing. And so, can we talk about research that's in the department and or research that you're all specifically conducting and what it means to do research? Jiachen, maybe we can start with you.
Sure, yeah. I think I already pretty much like give a little bit of
You did,
intro
yeah.
of our research, right? And the overview of the variety of research topics you could choose from if you select environmental engineering as your major, like ranging from air quality measurements and modeling to water quality measurements and treatments. And I guess I would just add that, there's plenty of research opportunities as an undergraduate student at USC, and especially in the School of Engineering. There's a program called Curve that pairs students with faculty in the School of Engineering, not only in our department, but also in other departments. Because I also got students who majored in computer science joining my lab. So there's some flexibility regarding who we want to conduct research with. And the school will pay, I think, around like $1,000 or so to the students, and also pay the PhD mentor in the research advisors lab, so that you have sort of a commitment that you will have a dedicated mentor, like guiding you through this process. And as the professor, I also meet with the students and welcome the undergraduate students to join my research lab and participate in my group meetings. So I
And I'll
think,
say that does not exist everywhere, right? So I did my undergrad at NC State, and I wish I would have had an opportunity like that, right? So you get paid to do a little bit of research with a professor. We post the research projects on a website. We advertise those research projects, right? We have a webinar similar to this that's a little bit more open where everyone can see one another and can ask questions to the professor about the research project they would be engaged in and kind of rank their priority of choices of what lab group to join. So that's actually a very exciting program and lets you dabble in research without having to like commit to doing say a graduate degree. You can kind of learn along the way whether that would be something for you or not.
right. Very good point. And I have to say that I did some undergraduate research back at Peak University, and that was not paid at all. So it's good that USC is having this fellowship program and also this system that helps to facilitate it. Oh, they also have a symposium, I think, at the end
Yeah,
of the program. So you can showcase your work and meet with your peers. So I think that's very cool.
like a
But
science fair on
beyond,
steroids. Sorry, go
yeah,
ahead.
beyond Curve, there are faculty members that maybe aren't participating in Curve, or they already have somebody that they're mentoring. And you can also do a little bit of research just on your own with a faculty advisor, working with their group, working with their students, if you want to, if you want the experience. And sometimes those professors, while they don't have the Curve funds, sometimes they do have undergraduate research funds from their grant awards. So they can pay you a little bit as well. So, yeah, getting paid is great, but the experience of dabbling with research and understanding if it's something for you is as Thomas said, he didn't have that opportunity. I didn't have that opportunity at my undergrad institution either. So, just if you're interested to try it and you don't get into Curve, there's still options.
Great.
And
Um,
in general, right, our department, as we mentioned, is very interdisciplinary. So the research kind of reflects that. So we have people that are doing very applied research. We have people that are doing very kind of fundamental mechanics research and material science research. Um, I mean, we have this rewater center, so there are people that are going out and working with parts of LA, Department of Water and Power, bringing in speakers that are can speak to these issues as well. So literally testing membranes. How do membranes work effectively in separating contaminants from water? All the way down to people like myself, I guess, that are working on at the small scale, how do ions even move through these porous structures? One cool research project that I'm doing now is we're taking carbon. This is kind of a waste product, kind of like graphitic carbon, and we're mixing it into cement paste. So cement paste, a structural material used for buildings, right? And by putting this carbon, if you put enough of it into the cement paste, you can still use it as a structural material, but it's also electrically conductive. And if you arrange it in a way that creates an electrical cell, you can also store energy in it as a capacitor. So we're looking at ways that storing energy in uh, in components of buildings, right? You could imagine that your concrete foundation actually takes up quite a bit of volume. Is there some way to charge that volume with electrical energy, maybe from solar panels that you could then discharge in the evening? That's kind of one interesting research area that
sort
my
of
group
turning
is
your
looking.
foundation into a giant power bank.
Kind of, yeah.
That's amazing. That's really cool. I'm excited for that. So where do we sign up? How do we get that installed? Okay, we're gonna get that now, right?
But
Looking at my energy bill, I'm like, okay, I think we need that. That sounds good. Very cool. Thank you. Let's switch gears to the other side of this. Oftentimes students are wondering, sounds cool as a major. What will I do in my career? And I'm not asking for stats necessarily, but I'm asking much more maybe on an anecdotal basis. Where do our grads go on to work? What do they end up doing after leaving their undergraduate degrees? Whoever wants to jump in.
It's been my observation that our undergraduates either go two routes. They go straight into a job, and we have a very historical reputation of they know they can, if they hire USC graduates. From the start, they're very high performing. So, I mean, just to get into the Viterbi School of Engineering, you have to be high performing. So to start, they're amazing people. But our program facilitates their growth, and they continue to be amazing. So we have a very, very high track record of employment. But Many of our students, we have a program called the Progressive Degree Program, the PDP, where part of your senior year, if you sign up for it, part of your senior year courses can double count for your undergrad degree and your master's degree. And then you only take 1 year to get your master's degree. Now, some people decide to work and do that progressive degree at the same time. So maybe they'll take only night classes, or so it might take a little bit longer. So it's a popular program. Not everybody does it, but it is a means to get a master's degree with some economy, and still continuing in our good program. But then the third type of students will go on to get master's degrees at other universities. Maybe they just want to experience a different part of the country or a different part of the world, and so they choose that route. So I have not had an instance where I've seen anybody who just can't find a job, so or don't have any options. So I think we give our students, or poise our students well for success in the future.
Yeah, so I've also seen kind of a variety of joining structural engineering companies or parts of the city, right? Different city agencies that deal with. Jiachen used to work at was it CARB? It's called CARB, right?
Yeah.
What were they in charge of?
California Air Resources Board. It oversees like all the air quality and climate change mitigation efforts in California. So it's a state agency.
Right. So there'll be a lot of students interested, again, like making an impact on society. So joining things that directly touch on the way people live, right? Um, what I'll say too is, right, and this is a plug maybe for engineering in general, you become a problem solver, right? So you, as a civil engineer, certainly don't have any restrictions on what you can do later with it, right? You're a problem solver in the end. So people end up also using their degree to do things like consulting or going into, say, patent law. Or I've seen people also end up going and getting like a pre-med degree later, right? In general, you're a problem solver, and of course, we hope that you in some way work on the built environment. That's our passion to improve the built environment for society. But you're not limited by what you do with civil engineering, and the you still have plenty of opportunities in the world to do whatever you please after it. Right? The engineering degree in general is very enabling, right?
Absolutely. Just to give
I
a couple of,
cannot agree more.
yeah. Just to give a few examples for all of you out there. I mean, obviously some of these construction or structural engineering companies like Turner or Morley Builders, Matt Construction, KPFF, all of these are strong recruiters. Our students have strong pathways to each of these different companies. CH2M Hill, which is like chemical engineering, environmental engineering consulting company. All of the different state agencies are definitely recruiting, government agencies. It just kind of keeps going and going and going. And there's often, to Thomas's point, it's not necessarily you have to go to a company that's quote unquote a civil engineering company, because many companies are looking for engineers not only for problem solving, but maybe they have an interest in their built environment or in their infrastructure. And my favorite example is Intel. Intel has consistently hired civil engineers because they need civil engineers on staff for all of their future growth and all of their factory development. And they have a whole team of civil engineers that they're looking at. And students always find it weird that Intel, this chip manufacturing company, is hiring civil engineers.
That would be my plug as well, always, is because so there's so many people going into computer science and AI, and I think that tool is great, and we do need a lot of people working on that area, but we also need these people that are very discipline specific, right? Have that discipline specific knowledge, and AI is going to have to interface with this. And people have to guide certainly these new tools in the right directions. So we need people that understand how to do civil engineering in the future too, right? It's just a question of sometimes, is it the computer scientist that's solving this problem, or is it the civil engineer that's adopting these new tools that computer scientists are creating? And I'm quite firmly of the belief that everyone's going to become adapted to these new tools, and the civil engineers will be the ones that are continuing to solve the civil engineering problems.
Absolutely. All right, so let's get back to my questions. I think I moved them off the screen. I got to find them. Here we go. This is going to be my last question. And so for all of our audience members, this is your opportunity to get your questions ready. After I ask this question, I'm going to open up the Q&A. You can start, go ahead and typing questions in. And if you see any questions you like, upvote them. We're going to go through those questions in the order that they are upvoted. So my last question that I'm asking is for everybody here on our panel. What are you excited about in the fields of civil and environmental engineering that you see coming, or like in the tea leaves here for the next 5-10 years? What's the future of civil and environmental engineering? Thomas, your battery cement is probably my favorite.
I mean, that's
That's what we're calling it, right? Battery cement. That's that.
yeah. It's an electrically conductive energy storing cement. Those types of things are definitely very excited. So this energy transition, how do you right now a lot of our power is coming from centralized sources. So how do you adapt cities to kind of decentralized energy sources? Mobility is going to change a lot, right? You can already see here in the streets of LA these Waymo cars, right? These robot cars, AI-driven cars without drivers driving around my neighborhood all the time. I've taken it a few times. It's really exciting. So I don't know, do people in the future just subscribe to a service like this? And how do you adapt cities to handle this type of change in mobility? So, again, like policy and engineering at the interface again. Um, uh, like a big one for us too is making cities resilient, right, to changing environments. And I think our environments will be changing quite a bit in the upcoming decades. And so how do you adapt cities to be more resilient? I think that's a really, really interesting question to answer.
Yeah, like resilience adaptation to climate change, for example. So it's like a really like a grand challenge that requires multiple expertise, which we
Mhm.
happen to have in the department.
Yeah.
And the other thing, I think, kind of similar to Thomas talk about like the AI. I think there will be, some changes in how we um, utilize AI and data science. For example, for my field, like we typically use the physics and chemistry-based models, but they're very computationally expensive. So potentially using machine learning approaches could provide us faster results and also help us like solve some scientific problems as well. So I think, our department is already very interdisciplinary, but in the future you'll become even more interdisciplinary because we're trying to be the problem solvers, and that requires collaboration of different disciplines and expertise and domain knowledge.
What I find very exciting, even though I'm not an environmental engineer, is a couple years ago, the environmental engineering faculty received Thomas and it's been previously mentioned on this panel. It's called the Water Reuse Center. So studying things like desalination and going directly, they call it toilet to tap. So if this unfolds, if they've got it's multi-year project, a lot of people working together, I'd be really excited to see how we can be more efficient and less wasteful in our freshwater use and reuse. I'm excited to see that.
Absolutely. Yeah, the rewater stuff. Jiachen, thank you for putting that in the link. The Q&A is open. If you haven't seen it, at the bottom of your Zoom window, there's a Q&A button there. You can click that and ask your question. For all of our panelists, you don't need to pay attention to it. Just listen to me. I'll guide us through them, and we'll go through these and answer them live. As many people are watching the recording of this, and so we're not going to be typing anything into the answers. We're just going to be talking through them, so everybody can see the recording a little bit later on. But go ahead and upvote, and we will go through those questions in that order. So make sure you keep asking questions, keep upvoting. It's up to you all what we do next. So the first question that has jumped to the top of this from Saper Oshidari is, how would you say the job security is in regards of civil engineering? And I'm going to start off this one now, and then you guys can jump in. the world is always in need of and will always be needing infrastructure. The built environment, as has been described so far, is everything that we need to survive. Human beings do not exist without civil environmental engineering. And as we talked about in the beginning, every single generation of engineers create technologies that have unintended consequences that likely result in the need for environmental engineering. This is the cycle we've been on. Now we're trying to change that and obviously get into some, removing the old linear take, make, waste model. We're trying to figure out how to create circular supply chains and the reuse, the rewater stuff. This is all where we're going in the world. We're never going to push a button and be done with any of these problems. Like if we were, we would have done it by now. This is a constant problem-solving technique of surviving as human beings with infrastructure, systems, and the built environment. Always in need. So that's the thing. Job security is fantastic, but I don't know. I don't want to put words in everybody's mouth, but please jump in.
I think that's very true. And if you think of like a civil and environmental engineer, they're always held in very high regard in society, right? Like you think of doctors, you think of civil and environmental engineers, you think of, I guess, lawyers, right? They all of these are always held at like they have a good reputation. You as have a good reputation in that job role, I think. And there's always a steady demand for civil and environmental engineers as well. For instance, right now in tech, there's this oversupply a little bit with respect to people looking to join computer science programs, and it kind of fluctuates up and down pending the market. Obviously, civil and environmental engineers also have to deal with the market a little bit, but I think that the need for good civil and environmental engineers is very steady and will be steady in the future.
Okay, great. Sorry, I took a lot of your thunder away.
No, so like I guess one thing I wanted to say too, I went to this. So at the end of our program, we have this thing called the hard hat signing. So everyone that kind of gets through our degree program gets this hard hat that has a civil, like Sunny Astani Civil and Environmental Engineering logo on it, and then you with all of your friends kind of get to sign with a Sharpie, and some professors are there as well, that your instructors kind of sign and put a message on your hard hat. But during that event, probably there was like 30 or 40 students there, right? And they all kind of got called upon to say what they're doing next, right? And I think everyone but maybe two students, if my recollection is correct, had a company, like a job that they were going to work at, identified in their basically leaving their senior year. So the jobs are out there certainly for civil and environmental engineers.
You bet.
If I can address the question about the FE exam, I just magically happen to have the numbers with me in front of me from our past ABET evaluation in 2021. Over a 5-year average, the national pass rate was 62%. USC's pass rate was 86%. So our pass rate is almost 25% higher than the national average.
Thank you.
And I just yesterday, a student came up to me and said, "I took the PE exam last Friday and I passed. I took the FE exam last Friday and I passed." So.
Even though you went off script, Amy, and that's a question that was not upvoted, I'm sure it is a very helpful.
I'm sorry, but I just saw it.
I know. It was the first question asked, so it popped to the top. But no, it's a great thing. I'm actually glad you did it, because it did get bumped all the way down. And the idea is, just for people that don't know, similar. I like to equate it to like when you're a lawyer, you take the bar. As a civil engineer, you kind of you go EIT, then you become a professional engineer, you get licensed, and that's something that you end up doing. Our students are very successful, no questions, no doubts. All right, let's get back into this. David is asking, how do study abroad programs work with a civil engineering major? Real quick answer on that one, David, is that it works like anybody else. We strictly create our study abroad programs not major contingent, and so all of our engineering students have the same opportunities. And we have things where you can go as linked to one of your courses that you take during the fall or the spring semester. We have summer programs. We have alternative break programs. There are a number of different programs where you can do global exchange, so you can go to another institution. It just kind of depends on specifically the institution where we have the matching curriculum, but we have lots of opportunities to study abroad, and civil and environmental engineers study abroad just as much as anybody else. So it's there for you. Ashmit is asking the next question. Oh, no, it got bumped up, so we'll get to the next. The next question is from Sophie, and Sophie's asking, what opportunities do you wish more undergraduates would take advantage of? It's a great question, Sophie. You're looking at these students through your classes, and you're like, why aren't you doing X?
Honestly, I think they're already doing a lot.
It's hard to look at our students and be more like, when do you sleep? Like the amount of things they do.
Yeah.
Yeah. And then one thing I think we should highlight is the DAS family entrepreneurship or innovation competition.
Yeah.
So I think that's also a very cool program, and it was very impressive. I mean, our students were very impressive when I saw them like pitching their startup ideas, and so I think I don't know if Thomas or Amy, you may have like a better overview of how the program works. But to me, it's just like when I attended the final day of the demo day, all of them seem to be very professional, and it's hard to believe that they were able to accomplish this while taking all the courses and enjoying their campus life. Yeah.
Yeah, this is specifically an entrepreneurship competition in the
Mm-hmm.
Civil and Environmental Engineering department, which is on top of all of the other Viterbi School-wide entrepreneurship competitions and USC-wide competitions, which is very unique in that there is a very specific one for Civil and Environmental Engineering students, just to kind of catch everybody up.
I think our undergraduates are all really involved. There are numerous civil engineering engineering clubs, extracurricular clubs. There's the American Society of Civil Engineers student chapter, and there's like a big design competition where every single subdiscipline of civil engineering has some kind of competition. There's the Construction Management Association. There's the Earthquake Engineering Research Institutes. And so there's so many things to choose from. And I think pretty much all of our students are involved in something. Some of the students are involved in research. And I think there's so many options. And like Jiachen said, it's amazing that they can manage and juggle their coursework and all these activities at the same time. So it just depends upon your own personal, what you're interested in. I kind of wish all of our students would get involved into research, and all of our students would go and become professors. But as far as the numbers are concerned, I don't think that's possible. Because faculty life is pretty rough, but and a lot of parents would be like, "Dude, I spent all this money on tuition. You go get a job." And so, it depends on their personality, their kind of family dynamics, whatever whatever they're comfortable with, their financial situation. But there's so many options for involvement, and every single one of them goes on their resume and gives them experience meeting deadlines, doing engineering or doing fundamental science or learning, teamwork, budgeting. There's so much experience from all these clubs.
There are just so many opportunities, right? And the biggest mistake you can make is being too timid and not taking that step forward and getting involved in something you think you might have a passion for, or you have a passion for. That's something I wish I would have done more as an undergrad than I did personally. So that's my only suggestion. Like there are plenty of undergraduates that I'm very impressed by, and those are the ones that are really involved and giving their input to everything. Being a little bit extroverted, right? Of course, you could be an introvert and be very successful as well. There are just so many opportunities at USC, and you just have to take the step forward and get involved.
Just to add my 2 cents, something I'm noticing in the current generation of students that are coming here is when students arrive, there's some students, not all, there's a hesitancy to get involved because they believe they're here to focus on their grades. And I hate to say it, but that's kind of a first step to not doing well in class. the involvement opportunities, getting involved right away. Of course, there's a limit to this, right? There's a moment where you peak past that, but the involvement is where you find community, is where you find friends, it's where you start to actually create study groups, and as a result of that, you do better in your classes. And so these involvement opportunities are not just like bonuses; they're a key part of your undergraduate experience, where you will then therefore find success. And so please keep that in mind. That when I see students come in, I really wish more students really got involved as quickly as possible. Please get in there and upvote. We only have time for probably like 2, maybe 3 more questions. And so if you want that question to be answered, get in there and upvote it and push it to the top. Our next question is from Ashmit. Professor Amy, you mentioned that graphics courses and design skills were part of the curriculum. Can you please elaborate on skills that would be applicable to civil engineering, like industrial design, sketching, drawing? I think maybe explain what you're getting towards the graphics courses, because it's not necessarily sketching, drawing, but you were talking more about the CAD stuff.
So they learn AutoCAD, which is just a general graphics software, but then they also learn Revit, and there's I forgot what it's called. It's like AutoCAD. That's more. So Revit is for structural engineering, but then when you're doing site design, so hey, where are we going to put the water main for this building? Where are we going to have the sewer line come out? Where are we going to have the electrical lines come in? All that stuff requires different graphics, and there's like a Civil 3D or something like that. So various graphic software, because you have to develop plans and communication. I always just tell the students a picture speaks 1,000 words. The first step in solving a problem is draw a little sketch of it. So if you clear sketching, language, knowing how to communicate something with a picture is an essential skill in all fields. I mean, if you want to draw a schematic plan of a wastewater treatment plant, you have the settling tank, you have the digesters, you have the aeration tanks. Where are you going to put these, and how are you going to describe where they're located? So it's just basically graphic software like that.
Great, thank you. Next question got bumped up pretty quickly here is from Kabir. Kabir is asking, what is the best way to prepare for this major before we enter college, if there is any? This dips a little into the admission world, which I said I wouldn't talk about, but I do want to say this. As long as you're in higher level math and science classes in your school, that's all you need to be doing. Nothing extra. If you want to do more, hey, great. But like, as far as admission concerns are, we want to see that you're prepared for the discipline. So that's math and science. Go to one of our admission events to learn more about that. And my personal recommendation, but I'd love the faculty to jump in, is don't get ahead of yourself. We got plenty of work for you here. You'll get here, you'll be fine. If you're excited about the discipline, that's usually all you need to prepare. Like, if you're excited about this and sounds good, go for it. But any other thoughts on that from a high school perspective?
No, I think that's right. So you need, obviously there's quite a bit. It's engineering, so you'll need to know a decent amount of math, right? I know students here take their calculus classes and might even get into a little bit of like differential equations and linear algebra throughout their curriculum at USC, not before you get here, right? But otherwise, if you're curious about or interested and passionate about the problems we talked about, the most important thing.
Thank you. And Kabir gets back-to-back prize for this one. He gets back-to-back questions being answered. He also asked to Jiachen, you mentioned that policy is part of civil and environmental engineering. Can you please dive into that a bit more, and how students like our audience here can learn about ways to implement such policy in our careers? Or can you explain what in the environmental policy elements?
Sure, yeah. So I guess like we don't have a course like you need to take about policy in environmental engineering major, but I think I myself and my colleagues, we try to incorporate, a little bit content in the teaching so that we can provide the context regarding the problems and possible solutions. Like for example, in my course, they invite guest speakers, and some of them come from the local government agencies, and they also kind of like sponsored our course projects so that students can work on like a real project that potentially have some real world impact. So I think in that sense, I think students could learn, could be connected with these policymakers through our classroom and also seminars and the other resources at USC to first understand like what are the problems the policymakers are trying to solve. And then there will also be opportunities to do internships at those agencies. Like my former employer, they're like hiring student interns. So I think it's that I would say that there are plenty of opportunities, especially in Los Angeles and California, for environmental and civil engineering. So I think for students to get more exposure to these fields, you just need to grasp opportunities offered in the classroom and on campus, and be connected with those professionals.
I'm putting a link in the chat for everyone to read a little bit more about one of our environmental engineering faculty members, Kelly Sanders, because she spent the last year working as the Assistant Director for Energy Systems Innovation within the White House's Office of Science and Technology Policy. Amazing write-up because she talks about what she learned in that process and some really cool things that she did as part of that process. So environmental policy is definitely engaged, but one of the biggest differences between environmental science as a major and environmental engineering is that environmental engineering is about creating the technology that's going to do the cool stuff, that's going to do the cleaning, that's going to do the reusability of things. Environmental science is much more the policy side of things. That doesn't mean you can't still take classes in that, and maybe minor in it, or maybe take a couple courses just for fun. But it really is a question like, do you find yourself more interested in policy by itself or on the technology side of things? And that is the biggest difference between environmental science and environmental engineering. I know a lot of students get excited about environmental science from high school, and that leads them here. So it really is a question of, do you want to make and build stuff that's going to make a difference? That's environmental engineering.
And I think Kelly would talk about her experience in the class that she teaches as well, energy systems and environmental trade-offs.
Yeah, a class that you'll actually take. So there'll be a big part of that.
And in the end, environmental policymakers and environmental engineers will work together. You're just more on the building side of things.
Absolutely. Never isolated, always working together.
Yeah. Yeah, my previous position started as air resources engineer in a policy making agency. So they really need all of this expertise. Yeah.
Great. And our last question is one that I'm going to answer because it's really about policy at the school. It's from Ray. It says, how difficult would you say it is to switch majors within Viterbi? It is not difficult at all. You can always switch majors. If you're admitted to the Viterbi School of Engineering as a first-year student, then you always have the opportunity to change your major should you wish to do so without any friction. My advice to you in the application process is to not overthink this. You pick the thing that sounds the coolest to you. If that's civil, or if that's environmental, or if that's something else, you start there, because when you're admitted, you're going to start taking classes immediately in that discipline. And if you don't like it, then you can switch. But don't worry about the application process, because there aren't any easier or more difficult ways to be admitted. There aren't any impacted programs at the school. So it's not harder here or easier there. Just put down the thing that you want to study, and that will also help add more information and kind of some authenticity to your application when you're talking about why you want to study something. So don't play games in the application process. Choose the thing that sounds most interesting to you and really trust your gut. With that, we've reached our hour, and so I do want to again repeat my thanks. Thank you again to our professors, Jiachen, Amy, and Thomas. I really appreciate you taking the time to spend with our prospective students here. For all of you that are out there that are thinking about applying, if you would like to go to our admission events, go to our admission website, viterbiadmission.usc.edu/events to go through the admission process to learn about all the things that are happening there. Make sure you check our website for the application deadlines this year, and do not miss those deadlines. And if you have any further questions, you can always reach out. But thank you so much. If you missed any part of this, the recording will be up on YouTube within the next 24 hours on our YouTube page. So thank you so much. And again, thank you to our faculty. Have a great rest of your evening, everybody. Bye-bye.
Thanks, everyone.
Thank
Thank you.
Bye.